Hello, everyone. Thank you for joining us today as we come together to learn more about machine learning simplified for developers with ML.NET. My name is Hassan Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there's something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is JK. JK is a senior software architect with 10 years of experience in software engineering. JK worked on full-stack.NET development, mobile applications, and Microsoft Cognitive Services. JK worked on some of Australia's largest corporates with great customer satisfaction. Feel free to ask questions during today's session. We'll have regular stops to answer your questions, and also feel free to tweet about the session and tag us on Reactor Abu Dhabi and MSFT Reactor. And also you can adjust the playback settings to select the highest quality to enjoy the best experience in today's session. And keep an eye on the Q&A. I'll be sharing a few links and resources relating to today's session. And that's all. With all that said, I want to hand over the mic to our speaker to start the session.
Hi, everyone. Just let me share my screen, and thank you for having me. It's been the first time I have presented for Abu Dhabi, so that's very exciting. So hi, everyone, and welcome to Microsoft Reactor Abu Dhabi user group. I'm very happy to be here. It's very interesting to be able to present. Just a moment. Just need to move this away. It's very interesting to be able to present all across the world without leaving the room. And I'm going to present to you about machine learning simplified for developers with ML.NET, because getting into machine learning can sometimes be quite challenging. And hopefully at the end, you'll find that it doesn't have to be that way. Before we start, clicker thing done? Not yet. I am Jernej Kavka, or you can just call me JK. I am SSW Senior Software Architect. You can follow me on Twitter, GitHub, my blog, jkdev.me, LinkedIn, and I'm also an organizer here in Australia for Brisbane AI User Group. On day, I'm doing .NET Core and EF Core development, and at night, I really like to tinker with cognitive services and ML.NET. And just to show you how I present right now, this is kind of my setup. This is you, the audience, the robot. And in order to keep fit well in these challenging times, I really recommend VR because it can really get you moving without thinking too much that this is an exercise. So I really recommend it. And I also worked on a mini project called Cognitive Studio. So if you are interested in doing cognitive services, but you don't want to build your own applications to test out things, you might be able to test some of them in this little app. All right, so first I'm going to start off what was the story, what was the motivation behind me starting machine learning in ML.NET. Then I'm going to take a step backwards and I'm going to start talking about machine learning specifically, just a quick overview. So you have not just understanding what machine learning is, but also a little bit more appreciation what ML.NET actually gives us. And at the end, we're going to look at ML.NET Model Builder to do the actual demo. So the way how I started is like most of my project is I had a simple goal. And that simple goal was getting from the bank transaction descriptions on the left to categories with a simple goal of knowing where my money is going. So I could say, oh, okay, I did $100 on investments, I spent this much dollars on food and drinks and this much on education. And then I could say, okay, I need to balance things up a little bit. And this is a problem that I worked on for over a decade, really. And I was like, okay, I have on one side just text that I need to classify. And on the other side, I have the categories I want to map into. And really, over the years, I tried with Excel. I think in 2006, I started that. I think it even was 2004. I basically tracked every single transaction, every single cent it was in that Excel. And you can imagine that was hours and hours spent to make sure that I know exactly what it was going on. But there was no automated system at that time. So that's all I had. And then I started to code in C# in 2008, 2010. I was like, yeah, let's do a system where it allows me to export a CSV and then import it into my C# application, and let's automate all of that. That was somewhat successful until I go somewhere else to buy food or stuff like that, and it quickly fell apart. It was a lot of maintenance work with all of the rules. I tried with regex, I tried to do auto learning and stuff like that, but it ended up failing pretty quickly. And lastly, I was looking at machine learning. Like 2-3 years ago, I looked at TensorFlow, Azure ML, and other solutions to try to figure out, can I solve this problem? Because this is theoretically the best example of how to do machine learning. And just before I switch, just to get questions over here. So I looked at machine learning, and what I realized is one does not simply learn machine learning. And to better explain that, I think this image shows us the feeling that I had when I started to learn machine learning. So we start with one phrase, or they tell you, okay, you need to know neural networks, you need to know what all those connections means and stuff like that. And then it's like, okay, I learned that. Then when you learn that, and you realize, okay, there's so many ways to teach your machine learning. There's so many words. You need to first learn what those words mean before you even know what you want to learn, what you need to learn. And then what you realize is it's not really a rabbit hole. It's a rabbit hole off rabbit holes off rabbit holes. Like, I spent 3 weekends or 2 weekends learning, and in the end I was like, I don't think I'm any closer solving my problem. I understand much more about machine learning as before, but how do I actually do this? And what happened is most of my projects are done on the weekend, and like most of other projects, I end up not having enough time. And like a lot of other projects, they became failed dreams, and I kind of abandoned it. Until Microsoft released ML.NET, I was a bit skeptical though, I believe it was 2018. But until I saw this statement over here, without any prior machine learning experience, this is what got me hooked. And this is where I was like, hey, maybe I can actually do this. So what is ML.NET? Well, for starters, it's a machine learning SDK that works offline, and I love offline experience, even though I use a lot of online services. It's simple yet powerful. It already is being powered by a lot of Microsoft products. If you have a data scientist in your team, it already supports TensorFlow and Onyx. So it's not just about you being able to train with ML.NET. You'll also be able to consume already existing models that were trained for you. And it has one of the best samples that I found at that time. The examples were actually so good that it got me into machine learning. And my goal was actually achieved, mostly because of the GitHub issue classified GitHub example they had. So that's why I really loved the samples, because it really got me into machine learning. It really got me thinking, actually, I think everyone can do machine learning. They just didn't have the right introduction into machine learning. So, all right, so I hope that I managed to hook you on machine learning and that you're now very curious about how I managed to solve my problems. But I'll make a step backwards, because if I show you right now that you can solve your machine learning problem with a couple of button clicks, you won't appreciate as much that you can just press one button and your problem is kind of solved. Like, at least you get to the point of prototype, which is much faster than if we just start learning about machine learning from courses and stuff like that, where you actually have to spend hours and hours understanding things before you even start applying it. So all right, so what is machine learning? So the best way to explain that is to compare it with the classical programming. So in classical programming, we start with rules, which could be the specifications that your client gives it to you, and data. This is the input that the user enters in the forms, for example. And then you put this into classical programming, which could be the functions you write in C# or other languages, and then you output an answer. Now with the machine learning, what happens is it gets reversed a little bit. What we get is that we start with the data as before, but the data is a little bit different. Here now we have all of the possible combinations of the data with the answers, and we also have the answer. So we basically train, trying to figure out what would be the right way, what would be the rule to get from an answer, from the data and answer. So it's kind of flipped around, if that makes sense. We're trying to figure out the rule rather than write it. And if we go a little bit further back, what is the machine learning process? So first, we start with training data. And then we put all of the training data into machine learning training algorithms. That will result in a model. That model can be a zip file that contains a lot of data about the rules. That's the most common output. And the next step is to actually deploy this model. This could be the desktop and mobile apps. It could be the web application, or it could be IoT, like the Azure IoT Edge. But here is not this is not the end. This is only the beginning of the cycle, because now, once we run this for a little bit, we get some feedback out of the system. We collect more telemetry from the IT devices. We get feedback from the users telling us this is wrong, this is right, and things like that. And we use that to improve data, which we then feed back into the training data. I think we have some link in the chat, please. Oh, okay, that probably is not for me. So this is a cycle, like an ML ops, where we are constantly publishing newer version of model, which is an updated rules for the machine learning. Then people using that model, we get more feedback about the usage. We improve the existing data, and then we repeat the cycle. So this is how machine learning basically becomes continuously better by just iterating through more and more accurate data. All right, so, but that doesn't really tell us what is machine learning. And this is really hard to explain what exactly is machine learning, but a little bit broader view on it would be to split it up into multiple classes of machine learning. So one of those is, for instance, supervised learning, which is with labeled data. So we know the answer for all of our data. Yeah, we'll share the my Twitter and other social media details later. So we start off with classification. That is one of the most common subtype of supervised learning, and they are further divided to binary classification and multi-class classification. A simple example of binary classification is a tweet positive? And then you have from 0 to 1 an answer whether it is or it is not. The multi-class classification is basically you have some inputs and then you're trying to classify them into particular categories. One example would be we have some telemetry from cameras, for instance, or scales and from different various IoT devices of various fruits. And then based on that data, we can then figure out what kind of fruit they are. And that what usually ends up behind the scenes, if we don't look too complicated multi-classification machine learning systems, we have decision trees. Basically just a simple tree telling you yes or no based on various attributes. Now, the next most popular subtype is regression, which is essentially if you're trying to do house prediction or you want to do stock market forecast and things like that. On the other side, we have unsupervised learning, which is unlabeled data. That essentially means if you have data that you don't actually have a specific answer for it. Now, it's a little bit odd to say, how can you train a machine learning if you don't really have an answer for them what to learn? Well, the easiest way to explain this is how we're using that. One example is clustering, and clustering is actually used to do product recommendation. So what machine learning is trying to do is trying to bring together similar things. So for instance, if customers are buying similar things, it will say, okay, these customers have bought these products, which is the same as the customer that is currently buying all of this stuff. But that customer hasn't bought this thing yet. So let's recommend this. And this is essentially what product recommendation is in a nutshell. This compares it with other users that have similar products and then sees what products you don't have that they have. And a little bit more complicated example of that would be dimension reduction. So to explain this is basically the machine learning tries to figure out which columns have high value versus low value. So for instance, what it means is if you have a lot of columns, it can then try to condense it and then give you some useful graphs, for instance, to give you nice statistics on data where it would take some time for you to basically figure even how to visualize data. The other way would be data optimization. Say you have a lot of telemetry, for instance, or better yet, you have a lot of data for lots of products, and then you want to save space on your hard drive, and then you can do dimension reduction to figure out which columns might be redundant, and then you can delete them because the machine learning said that, hey, these columns don't really seem useful compared to the other columns. And the other one is reinforced learning. This is in a way my favorite machine learning because unlike all the other machine learnings, this one learns on the fly. So basically what it does, it tries something, it usually fails, it learns from its mistakes, and then it repeats that until it masters what we were setting to do. So basically it has a little bit different way of learning. Rather than telling it what we want to teach it, we're basically saying, are you on successful path toward what we want you to teach you? We don't actually tell it exactly what we want it to learn. So for instance, if we're driving cars, we would tell it, drive straight, but be on the road. So don't switch lanes, don't go off the road, don't crash into anything. These are the parameters that we give it, but we don't really tell it how to drive or if they're driving correctly or not. We're just saying how well they're driving based on the telemetries that we gave it to it. One would be the AI used in robotics, in games, and stuff like that, where we really want to have an AI that responds to a player or to an environment. All right, so this is really nice. We have some nice view on various different machine learning, but this is not quite all we need to understand to go into machine learning. Like, this is a good entry, but there's one layer you still need to understand before, for instance, you want to learn multi-classification. So if we zoom in into this, there's one last thing that you need to understand is that each of these nodes could have a different training algorithms. Now, ML.NET calls that as the trainers, and it gives you different trainers based on the subclass of the machine learning you want to use. So for instance, this multi-class classification has a couple of trainers. Now, the difference between those trainers is depending on your data. So if you have a large data set with with a lot of unique categories, for instance, that you want to predict, one trainer might be better than the other. Or if you have a smaller data set, the same trainer would be really bad. So you need to pick another one. And Microsoft has a good description of all of these trainers. So we won't go into details how they work. But if you're really curious about, there's a lot of graphs like this, where it really tries to guide you through what might be a good trainer for you. But you'll soon find that maybe we really don't need to know that. But it's a good thing to know that when we're doing a machine learning, these are the algorithms that do the actual learning. All right, now back to this graph. So what ML.NET actually covers is almost everything what you see, except for the reinforced training. Unfortunately, right now it doesn't do that, but hopefully in the future this is going to be supported. Okay, so how do you actually get started? So if you felt intimidated that, hey, this looks like quite a lot of work, so how do you actually get started? Well, you start with a scenario. So first, say, is the tweet positive? So how do you start if you want to solve this problem? Well, you look at the binary classification. So you want to do bank transaction categorization. How you start trying to solve this with machine learning? You look at the multi-class classification. You want to predict house prices. That's regression. Then you want to do product recommendation. That's clustering. So you basically try to first find what do you want to solve with machine learning, and then you look at what kind of machine learning can solve this problem. And there are a couple of caveats before we move to ML.NET for machine learning specifically. Machine learning won't solve your problem magically. Like, a lot of people think machine learning like magic. You just drop in data and it's just going to magically know the right answer. It's unfortunately not that. So what it means is you need to understand your data, at least a small fraction of it. What I mean by that is the process of machine learning training is kind of like trying to guide the machine toward the right answer. And you need to prepare the data in such a way that you allow the machine to learn the right thing. You need to choose the right algorithms so that it can learn the right thing. So imagine more that machine does a lot of the magic behind the scenes, but you still need to gear it in the right direction. And I recommend that you start with something simple like classification. Binary classification is one of the simplest one. Regression is a little bit harder to get into and a little bit harder to actually test if it does actually work correctly with classification. It's usually easy to see if it's way off or just a little bit off. So with that, I'm going to move now to ML.NET. I hope that you're not too scared about machine learning now, because now we're going to get into the simpler stuff. Now I'm going to show you how ML.NET allows us to just say, okay, I didn't really need to know that, but maybe it gives you some appreciation what is happening behind the scenes. And when something goes wrong, this knowledge might actually help you understand why it went wrong and how to fix it. All right, so previously I mentioned that ML.NET does not require you to know anything about machine learning experience. That's roughly what happened with me, but I learned a lot about machine learning through ML.NET. So the first thing that we do when we try to do something in ML.NET is it actually asks us, what are the scenarios you're looking for? So we have sentiment analysis, product recommendation, price predictions, and a lot more, and they're adding more and more cases. So you no longer have to think about, okay, I need to do binary classification, I need to do that. They just give you all of the various different scenarios where you can start think about, okay, I think I need this, and then you can start dig deeper to know what you actually need from the machine learning. And then we have training data. We replace the machine learning training algorithms with ML.NET, so we don't have to worry about that. And then in the end, we get the model. Just a little problem with that, however. So I mentioned about the trainers earlier, right? So if we use ML.NET directly, we still have to decide which trainer should we pick. Now, this might not be a trivial question nor a trivial answer, but we don't have to know that answer either, because ML.NET comes to the rescue. So what ML.NET Model Builder is, it's a wizard built on top of ML.NET inside Visual Studio. And what it does, it tries to pick the best trainer for the given scenario and data, and it allows you to do quick prototyping. So for instance, if you've realized that, hey, the model that I generated, it's really way off. It's not working the way I wanted, or the accuracy is terrible. You can go back to your data, make some changes, and then quickly retrain it to see if your changes did a good positive impact. And to install this, just open up Visual Studio from 2019 16.7 onwards. Write preview features on top, go to preview features, and enable it in the ML.NET Model Builder. Now, sometimes you don't actually get this option, so you can go to the ML.NET Model Builder website and click download. So if you go to get started, you'll get a similar instructions that I showed you earlier. Now, sometimes you need to install the extensions, sometimes you don't have to. I think they are currently deciding which way to go. But if you don't have the extension, this is the way to go. All right, so let's start with the demo. So the demo is going to be how to get from the bank transactions from the left to actual categories on the right. And to do so, I had to do some preparations ahead of time. So I needed to get the actual bank transactions. Then I imported those bank transactions into an app that allowed me to do manual classification. That happened across, I think, 3 years. So I have like roughly 3 years worth of data that was manually classified. And then I exported all of that data into CSV so I can consume it in ML.NET. So this is roughly how the data looks like. We have date, we have account, which is credit card or debit card. We have the category, which is what we're interested in. We have tags, which is something that come with application. Every category can have multiple tags. We have expenses, income, which is not being used because we exported only the expenses. We have currency, how much is the expense in the main currency, and the description, which is our main focus. So we're going to try to get from this column over here, description, and try to guess the category. All right, demo time. Finally. So I'm going to go here to Visual Studio. And one important thing to note here is you need to already have a solution and you already need to have a project. So if you go File, New Project, and you're trying to find machine, machine learning, yeah, you'll see that it finds nothing. Even if I search for ML, it won't find any solution for that. So what you need to do is you already need to have a project, right click, add, and click on machine learning. Then we do text classification, we do next, I select new file, select this file. Now I selected here a CSV. We can also select a SQL Server if you have the data over there. And what we do next here is very interesting. So we say, I want to predict category. So now it's selected category over here, and the rest of the columns is the data that's going to use to try to train machine learning to be able to predict this particular category. And the next step is train. So what's happening here is everything that I was explaining to you, from what subclass of machine learning to pick, what trainer to pick, all of the details that I was talking about, that happens with that one button click. So now it goes through various trainers and then tries to figure out which trainer would be the best one. And in just a short bit, we can see that it tried to use 3 trainers and it thinks that this one is the best one. I happen to know that that is the best one. And if you're curious about how long should you be training for this, you can just press 0 over here, train again, and you'll get this message telling you how long you should be training. Now take these numbers a little bit with a salt. You should look at the outputs. You probably should aim for at least 2 different trainers, maybe 3, depending on the data and how different the trainers are. For text classification, 2 are good enough. Usually the first 2 are competing which one are better. Usually the first one is better, but sometimes the second one wins. And it also depends on how good your machine is. So if your machine isn't strong, like your CPU isn't really good, or if you're doing streaming like I'm doing right now, you might have slower training. So you might need to increase the number. All right, so what we're having here is 94% accuracy, which is suspicious because that means that it's really, really good model. It's very accurate. But generally, unless your data is really good, that is a bad thing. It's like, it shouldn't be that good, should it be? Is the data really that clean out of the box? There's no contradiction, stuff like that. So what happens here is, remember that I mentioned before that we have tags over here, and this is what the application gave us, and it's kind of correlated with category. It's something that I manually entered. And the problem with that is, for instance, if I put as an input the tag taxi, you already know that's transport, but I need to know that it's transport in order to add tag taxi. So it's a data point that I wouldn't be able to know ahead of the time. So what I'm going to do is I'm going to remove this column out of the training. So we can actually select and basically remove the columns that we don't want to be part of machine learning training. So I'm going to do that. And if we train, say, for 15 seconds, we should get a little bit different story now. Also, if you have any questions, now it's a good time to send me some questions. Oh, all right. So now we see that we lost like whole 10% accuracy by removing that column, which makes sense because that column already told us quite a lot about that category. So we didn't give machine learning much to learn. It's like, oh, okay, if here is taxi and this is transport, easy. So now we have a more realistic machine learning model based on the data that we'll be able to supply. But I can tell you that we can make this a little bit better with just a sprinkle of data science. So if we go back to data and look back on the data on the columns, note here category, sorry, not categories, dates. So how do dates help to get a category? So if we think about what does the date tell me about transport? So they happen on the same day, but does it really help me link it to the transport? I mean, if it would be Sunday, Saturday, Monday, Wednesday, maybe that would actually be helpful, but not the date itself. The date is constantly changing. It's not really contributing to the category. And even worse, in this format, unfortunately, it's an Australian format, so it recognizes a string, so not as a date. But rule of thumb, usually dates and time don't actually help you with the multi-class classification and binary classification. They're very helpful with regressions, and they can be very helpful with binary and multi-class classifications if they are generalized, say what month it is, what day it is, and things like that. All right, we have a question over here. So we have a question, why less accuracy is a good thing? So the reason why it's a good thing in this particular case is because the high accuracy was high because of a wrong reason. So it was high because of the data we wouldn't be able to have at a time when we were trying to predict something. And when we removed that, we got naturally lower accuracy, but we got inputs that we can actually have at the time we want to predict the category. So we can have the date, we can have the account, expense, currency, description, all of that data can be available from the bank, but the bank doesn't give us the tag of the transaction. Does that make sense? I hope it does. All right, so back to the date. If you do multi-class or binary classification, you can safely remove the date unless you have day of the week, month, or things like that, more generalized and more repeatable data. What's going to happen when I train this? We should get slightly better accuracy. So we have 85%. So we got 1% up just by removing another column. So we're getting now 85%, but we can do a little bit better. Now, what I'm going to do now may not improve the accuracy, but it makes our model much, much simpler. So over here, I know that income amount is not being used. We only exported expenses, so this is always 0. So I'm going to remove income amount. I know that currency and main currency are always the same value, Australian dollars, so I'm going to remove that as well. They don't really give us much value. And expense amount and in main currency are also the same all of the time. So I'm going to choose to remove in main currency as well, because they're redundant. And now if we do train, we should get roughly the same results. We get 85%. Isn't that great? We remove so much columns. We gotten from 9 fields that we would have to enter in order to predict one category to just 3. So if I do predict over here, we can see that it predicts correctly. And I'm going to take my cheat list and put it on a different screen just to get some of the transactions. I'm going to put this one in, and this should be home and utilities. So if I tried another one, say this one, it's this one, predict, and I treat .NET Foundation as an investment into community, so that I predicted correctly. Now, if I go back to the original one that was pretty sure, there is a couple of things that I can tell you is a bit problematic with this model. I'll just switch back to here to see if there are any questions. Connect me. Okay, that's just connecting to LinkedIn. There's one problem with this. What happens if I change the expense? Say, do 110. It still works correctly. What if I add additional 0? Okay, now it thinks it's transfer. Why would it think that this transaction is a transfer? It's obviously not. So why does it think it's transfer? So what we did with our model is we made it highly biased for instance, for transfer toward high value. So if an expense is high, it will just make an assumption because it's most of the high expense amounts are transfers. It will just say, okay, there's a strong correlation between $1,000 in transfer. So if I see $1,000, I'll just say that it's transfer. I won't even look at description. Now, this is obviously bad. And in this kind of scenario, when you really look at your model and at your data, you're like, do I actually need expenses to predict the category? And usually, at least in this case, you will find out that no, you actually don't need to, or when you do need to, you can actually make a separate model where once I get a categorization, I can then take that categorization with some extra data and then make a more accurate sub prediction, if you will, for that category and bank transaction. So I'll go back to data, and what I'm going to do next is I'm just going to remove expenses, because based on my training, based on the way that I looked at my data and do the training and all that stuff, I realized that I actually don't need it. So I'll train that. So this will take a little bit. And this should be done now. And there's also another thing. See here, account. So this, I thought it was a good idea back then, but then I realized, hey, if I change from credit card to debit card with all my transactions, or vice versa, all of a sudden, all of my predictions are less accurate, because it made a strong correlation between the account I'm paying and the description with the categories. So for instance, if I change this, I think it was debit. If I change this, for certain cases, it will just not work correctly, because it was really expecting just one specific account. And in some cases, it just partially looked at the description and said, okay, that's good. But what it also means is, if you went from one bank to another and they changed the account name, you will automatically have lower accuracy on all of the bank transactions for no good reason. And for that reason, I'm going to remove this column as well. I found out that this is not really a column that basically give me a lot of value. But what we'll notice is, when I train, we might actually see a little bit of a dip on the accuracy. So we went from 85% back to 84%, like our second run. Now, you want to have your accuracy as high as possible, but also keep in mind that when you have more columns, more data, you have more variations. And even though it's more accurate based on the data you put in, it might be less accurate toward the future transactions. So you would need to test your data with real data and future data to actually see how accurate it is. This is just giving you a ballpark view how accurate it would be. And the way this is achieved is by taking all of your data. In this case, it's 2,500 lines. Split it up in half randomly. So it takes 50% randomly for training, and it takes 50% randomly, the other 50% randomly for evaluation. And what it does is, once it trains those 50%, it generates a model, and then it takes the evaluation data set and it compares it against model. And then the number that you get is the number how much of that evaluation was wrong. So if you have a lot of unique values that only happen once, you will never reach 100%, because it either has to go into training or it has to go to evaluation. If you have always duplicates, or at least somewhat related, so say that at least one part of the text exists in both, then there's a good chance that the model will learn the right way, so you don't have to, so that it will be able to find it and train for it. All right, are there any questions so far? So I think I answered all of the questions so far. Oh, we have one, Mehmet from Melbourne. Hi, Mehmet. All right, so we are now going to try something else. So when I try to predict this, Can I move this back? What did I do now? I'll just move this down. So when I try to predict this transaction, it works perfectly fine. It has even high accuracy. Now this sometimes works, but most of the time it doesn't. If we change one letter, now it thinks it's food. So this is a really funny thing that happened on a lot of demos and quite a lot of clients. And they're like, why does it happen when I change just one letter? It's completely wrong. So the reason why this happens is quite a funny one. So the way Microsoft decides, if I open the Excel, so what happens is this description, this column is being treated as a hash categorical, as a categorical hash, and it hashes all of the values in this column. And the reason why it does that is because if we highlight all of the duplicates, there's a lot of duplicates in it. It's, you know, if you have bank transactions, you have regular transactions, you go to grocery store, you go out to eat and stuff like that, and they are very repeatable transactions. And what happens is that the data set that I have enough duplicates that it thinks that this column should be categorical. Now, if there are less duplicates, what it does, it says, hey, this should be a text tokenizer. And what then happens is, rather than hash the entire word, it actually splits it up. Now, unfortunately, we cannot do this through the model builder just yet. I complained about it to Microsoft for quite a bit. But if you get to this problem, but everything else seems to be working, like if you put your full text in it, it recognizes it perfectly. You don't have to worry about that. What you can do is we can go next step. And what I'm going to do next is generate the code. Because what we can do is fix it in the code and retrain the model. But before we go to that, I want to show you what do we get once we generate the code. So over here, we have model input, which is the input that we'll do into the machine learning model. And it reflects the data structure of your CSV. You'll get all of the columns, even the ones that you ignored. Excuse me, because what happens is it also generates code for retraining. So it needs to know how to read the CSV correctly so that it can retrain. And then lastly, we get the model output, which we get the prediction, which is string, and also score, which is all of the possible outputs, all of the likelihoods of the category that could be correct for this prediction. Now over here we have the ML model zipped. I'm not quite sure exactly all of the data that is hidden inside. I've tried to dig into it, but there's no specification to my knowledge that allows us to quickly pass through and understand exactly what the content is. And I think we have a few questions. Isn't reinforcement much more accurate in training a model? So we have a question regarding reinforcement learning and if it's accurate. It can be, depending on how well you define the rules of learning. Because with reinforced learning, you just put it into an environment, or you put it in 3D world, for instance, if you're doing driving and stuff like that, or you have image that it recognizes it. And then you just you do just a fitness score. And if you set up the fitness function incorrectly, it can go very, very wrong. It will try to find shortcuts that you have not anticipated, and it will learn very wrong thing that still fits your fitness function, and it will run with it because it's easier to go with it. So yes, it can be more accurate, but it's almost like a child. You have to guide them toward the thing you really want them to learn, not to wander away. So how would one try to make out a high amount of bias as possible to get the most fair model possible? That's a really good point. Making unbiased models is really hard because we are biased, and trying to find biases as a human, especially if you're just one person, is really hard. So having multiple people looking at data helps you. But sometimes what you can do is you can say, hey, we won't look at the biases right now. What we're going to do is machine learning, and then try to do random inputs to find out biases. So basically you go through trained model, and then you're trying to do various inputs to find out how biased the machine learning model is, and then reverse engineer why the machine learning is biased. I think this is going to be one of the easiest way to find biases in the data, rather than trying to look at the data and try to figure out how the data is biased, if that makes sense. And the last question before we continue, if you have 20 columns, how would you be able to figure out which columns are impacting the model prediction? Is there an easier way to identify these columns? So yes, they are, but as far as I know, not in ML.NET right now. They are, you can do weights for columns, but that's very, very advanced topic. And if you like, you can contact me and I can show you a few things. So with the questions, just because they were piling up a little bit away, I'll go to the consume model. So the consume model over here has the reference implementation, how you can use the machine learning. So this is a class that you can use in any of the application. It's .NET Standard 2.0, so you can actually use it in .NET Framework or .NET Core. Sorry. And what it allows you to do here is you can just call consume model.predict. You can create the input model, which in our case is going to take only the description. You have other properties, but only description is the necessary one. And then it will return the results. It's very simple. And behind the scenes, it's going to create the prediction engine, which is going to load our model. Unfortunately, the path here is hard-coded, but you can refactor the code. And what happens here is when we load the model through the path, which is this ML model zip, we get the transformer. So this transformer is something you can cache. This method, as far as I remember, is thread safe, and it is safe to save this ML model, this transformer. But this on its own doesn't help us much. You can look at this like a connection to a database. A connection to the database itself doesn't really help a lot. But this is helping us a lot. So we create a prediction based on our model input and output and the model that we loaded from the file. And then we get the prediction engine. The prediction engine is not thread safe. So you should if you're doing dependency injection, it should be scoped. All right, so you literally just call one line and that's it. It's going to work. So if we go to the program.cs, This is a reference implementation in a cons application, and I'm going to switch to cons app, so don't forget. And what we do here is we are creating a sample data. It already generated one example with description. It put the sample data into consume.predict, as I mentioned before, and then it outputs a couple of things. So let's run this. So over here, we can see we have Spotify, it's leisure, and what you can say is that this first number over here is leisure. So if you're interested on how to figure out what these numbers are, if we go back to the Excel, these are the categories based on their first occurrences. So the first one would be leisure, the second one would be other, the third one would be transport, the fourth one would be food and drinks. So this is how you can figure out what each individual score over here means. All right, so that's that. And just to prove you that this is working, I'm going to take the .NET Foundation string. I'll paste it over here and run it again. So now we have investment. And what I'm also going to do is I'm going to take a cheat sheet and I'm going to replace this data over here. So what I'm just doing is just replacing the output. And the reason why I'm replacing the output is just to show you that we can have a little bit nicer output. And I think my categories are a little bit, yeah, I think my categories are a little bit out of line. I think I have done some changes to my Excel and my the categories here might be a little bit out of order. Then the thing that I want to do last is if I change one number here and run this again, it will choose the wrong thing. It's going to choose food. So how do we fix that? So this is where we go to this model builder over here. So this is the generated code, and you can even see that it picks up the actual path to the CSV that we used for training. And what it does is it has the code to generate the model. So over here we have the create model, that what we're going to call. And if you're interested, you can look at the build pipeline, how everything works. But what I'm interested is the build training pipeline, and most interested in this line over here. So if we look over here, we have the description. It's a little bit long, but you can see that it looks for the output and input column description, and it identifies it as one hot hash encoding. So what I'm going to do is I have this my cheat sheet over here. I'm going to copy this line, which essentially what it does, it specifies it as text featureized tags. That just for lining up. And what we have now said is, hey, I actually want this column to be recognized as feature tags. So it will split up the tags into multiple parts rather than hash it. All right, so let's go to the program CS. I'm going to do model builder dot create model. I'm going to return this. So once we created the model, we exit the application right away. And we have now a trained model. And you can see that the accuracy actually increased. So we have 88% over before, or actually 95%. Not really sure which number the model builder uses, but you can see that it's pretty high. And this is because we selected the right column type, which was misclassified by the model builder from before it even started to train. Here, a little warning. When I was doing demos, I usually said that you need to do rebuild. That's because it usually changed this ML model.zip and then rebuild, copied it into bin folder where your application is, so that you get the up-to-date model. Now with the latest model builder, they changed that. So now if you rebuild, it will actually override your model, a latest model. So you shouldn't be rebuilding, and you might also actually need to go to the bin folder and copy that model and override this one. Just a warning, I spent like 3 hours debugging this to figure out what went wrong. So if I run this, yeah, it says it's investment, and it's like 99% sure it is investment. So that is significantly more confidence from machine learning than ever before. Not only that, what I can do is I can delete a good chunk of it. And that wasn't expected. Wait. I think I know what's happening. I think the problem that I mentioned earlier happened. That the model is being overridden. Why did I have to change that? So, okay, so what I need to do is retrain this. Then I need to check, this is 9.11, right now we are 9.11, so that is the latest one, okay. And if I go into this folder, it is 8.51, so I'm going to replace this 9.11, okay. Demo gods, give me mercy. Okay, it doesn't work. So this is one of the bit of issues that you might find with machine learning, is that sometimes, because it randomly picks data, so you can see here, I changed just a little bit. I removed the left side, but kept the right side, and now it works perfectly. If I remove this part, yeah, it still works. So it doesn't always give you the results you were expecting, because we don't actually have a full overview on how it determines that this is an investment. So this is why it's important that before you just blindly say, this is it, we're going to ship to production, that you do some manual testing, you put it to your beta testers, make them aware, hey, there's some automatic stuff going on. And usually until you don't have really high confidence in your machine learning, you don't try to automate anything that would be, say, life-threatening if it's wrong, or it could do actual damage if something happens automatically without human supervision. But it is really, really great for automating processes where you already have to go manually through all of the things, and now you have just a process where, say, 80% of all of the autofills are correct, and then humans can fix up the rest of 20%, saving 80% or even more time looking at the data. So this is where this simple machine learning allows you to do, is basically automate autofills, auto recommendations and stuff like that, so that people don't have to spend too much time on this. All right, so this is for the demo. There's just one thing, two little things that I want to show you before I finish off. So one thing is, if you want to try this at home and you try to do with a low data set, say here I have machine learning that tries to learn rock, paper, scissors. What will happen is it will fail. This will fail because the data set is only 3. Now, technically, if you reuse your code, you can actually train it with just 3, but the ML.NET model builder requires you to have at least 100. So if I do with 100 repetitions of rock, paper, scissors combinations, now it will work and it will have 100% accuracy. So now you can make up the rules for rock, paper, scissors, like rock, paper, shotgun, and the machine learning can figure out the rule, which thing wins which. And the last thing that caught me with the very last version of Model Builder is that sometimes the space is replaced by underscore, but it's not being replaced by underscore everywhere. And that usually happens sometimes when you save your CSV in Excel. I'm not sure under what condition that happens. And then it tells you that there's an invalid column that it cannot read from it. And this is it. So if you have a weird problems not being able to read the columns, just replace spaces with underscores and it should work. Right. With that, I've learned how to import CSV files. We learned that we can tweak columns to get better results. Sorry about that. We have learned how to generate projects with machine learning, tweaking code that was generated, and some minor issues like if you have small data sets. And the last one that really pulled my hair for my workshop that I've done recently is the space. That wasn't a problem a month ago, so it was really interesting to go through that. You can, if you want to have a little bit more overview about the topic, Richard Campbell did an interview with me regarding machine learning and ML.NET and how you can use it in various scenarios. And with that, I'm happy to announce that my problems has been solved, automated, and despite having accuracy of just about 80%, for more than 90% of my transactions are actually correctly identified, because the ones that are inaccurate happen very, very infrequent. Also, if you're interested in learning ML.NET, there's a workshop that I do for NDC Sydney in a month's time. And with that, thank you. And I'm also accepting any questions if you have.
Thank you, JK, for today's session. And yeah, as you said, the floor is open for questions. If any of the community members still have a question on today's topic, please send them across.
Yeah, I hope I answered the questions as they came. Yeah, but it's a very broad topic, machine learning. Like I just scraped the surface with ML.NET, and ML.NET gives you so much simplified view on the machine learning, but there's still so much of it. I just shown you a small fraction that I do, for instance, for my workshops, and this, the data science, trying to figure out how to clean up the data so that machine learning works better. But the important part is that you don't actually need to know all of that to build your first prototype. You say, okay, the accuracy is 70% or 60%, which is, yeah, it's horrible, but you can actually try out if the machine learning would work in theory. And then once you figure out that it can work in theory, then you look into data science, and then you try to find how to improve it, how to get the high accuracy. And in some cases, the accuracy goes down for the things that you actually don't care. Like in my case, the bank transactions. I actually don't care that a bank transaction that I done once in Japan isn't classified correctly, because the likelihood of happening it again is very slim. So I'm happy for that to be wrong. But on the other hand, if my regular coffee shop coffee bank transaction is classified incorrectly, I'll be angry. So yeah, you have to take the accuracy a little bit with a pinch of salt.
There was one more question on data being imported from Power BI tables. Can that be
used?
I
forgot to scroll. Sorry about that. Yeah, I was stuck on the same scroll bar. I didn't even notice that there were more questions. Okay, let's quickly go through. Do we get feature importance from ML.NET? We do get if we do it from code. I can show you if you're interested in it after the talk, but it is a little bit more involving. Do you have samples for medical use in machine learning? So we have cancer detection and a couple of other things for machine learning. If you Google it, you can find it, but I personally haven't worked on any of those. Any other good resources to read up material on ML.NET? So you can go to, you can just search for ML.NET, and you should get this web page. So the one that is most interesting one is, need to search a little bit. So there is the documentation. The documentation is really good. ML.NET docs. Is this the one? Yeah, this is the one. I learned a lot from this page. So this one has trainers, it has what things are happening behind the scenes, and when you're more interested in more details, it has also samples, and then samples gives you more explanations. Can data be imported from Power BI? If it's from SQL Server, yes. If it has a SQL Server connection string, probably, but I don't know. Thanks, JK, for a very useful session. Thank you, Richard. Talk links. So I do have, I can share it later, but I do have links for that. I think it's in slide share. Yeah, that's it. So I can just give you the link right now. Can you put the link of workshop? Yeah, I can put it over here. Yeah, login. While I'm looking for that, you can ask me any questions, but I should be able to get my uploads. Okay, over here. So the last version should be 2 months, 1 year, 1 year. I don't have any earlier versions. I will give you, can I just upload the PDF over here?
You can send me the link and I will share it with the community members on the meetup page.
Yeah, let's do that.
Yeah,
and
sure.
I'll upload it to over here, and yeah, let's do that. And if you're interested in the workshop, I'm basically doing the same examples that show you here, but I guide you through. But then we go far more in depth. It's like a full day thing. We do data science, we clean up data, we go through a couple of more examples of machine learning. I just had one on Friday and people were really happy with it. Especially if you haven't worked much with machine learning, I think this is a good intro. I haven't started with machine learning, so I kind of understand the problems that a lot of developers are trying to tackle. So hopefully I'll see you there. All right, any other questions?
Well, I think that was it. Just requesting the slides, which we will provide later on the meetup page. And also you can connect with JK on LinkedIn and Twitter, and that will give you also more access to ask him questions and also to check out the resources and the slides and the sessions that are upcoming from like that you'll be doing, right, in different parts of the world now that we're doing everything online, and that you have a lot of engagements. I will start taking over the screen share now to share a few things with our community.
No worries. Yeah, the screen share should be yours.
Yeah, I'm doing that, just sending things live. All right. So there is this module which will be helpful and informative for you all to continue the journey and learn more about classification with Azure Machine Learning Designer. So I pasted the link in the Q&A where you can check it out and take that module. There are also more learning resources on Microsoft Learn, which will help you throughout the journey. So I highly encourage you to check these out. I also want to mention a couple of upcoming sessions that are happening this week. So tomorrow there is a session and there's a workshop actually on DevOps tools of trade. So from cloning GitHub repos to setting up an Azure pipeline, DevOps are critical to developing scalable and professional software. And by using this like proper services, you can plan smarter and collaborate better and ship faster the projects. And this workshop will be an introduction to a number of DevOps tools and resources that will prepare you for the next large project. So this is happening tomorrow, and on Wednesday we have a session on Java 11 serverless functions. And since the release and of the preview of Java functions, there is an increased number of users and organization leveraging these capabilities that are available in Java 11 serverless functions. Now it's available for Windows and Linux, enabling the development of serverless apps. And within this session, we will be covering all the different tools, Maven, Gradle, CLI, and all. And it will be with the Senior Cloud Advocate, Rory Preddy. So join us on Wednesday. And there are also more interesting sessions happening throughout this week and next week from like the global team in the Reactor and other reactors also globally. So I highly encourage you to check out the calendar on meetup.com. And don't forget to take a minute to take the survey. There is a session, there is an event code for each session, and this helps us understand more the topics that you'd love to see in the Reactor. So please take a minute to take this survey. And finally, don't forget to check out our YouTube channel and also subscribe to our newsletter. This is a monthly curated newsletter where we send all the upcoming sessions and interesting workshops that we're doing from different reactors, and you can subscribe to more than one location. For example, not just Abu Dhabi, you can subscribe to the global events that we're doing, and you'll get that straight to your inbox. And that's it for today. Thank you again for joining us, and we hope to see you in upcoming session. And that's it. Goodbye, everyone.
Thank you for having me, and thank you for everyone for coming.